what that is. It's actually not that complicated. Personally, this is my favorite lecture in terms of it really gets into sort of the deeper underlying elements. I would fully expect it to make your head hurt a little bit. We're going to do sort of a fairly rapid blast through the mathematics here. And you won't really have to know this really to effectively use it, although it's good to know that it exists, and that there might be pieces of it that you'll want to drive into deeper. And so, really the title of this talk is called Spreadsheets, Big Tables, and the Algebra of Associative Arrays. We've lectured on that topic in the past. And so with that, we will get right into it. So here's the outline for the lecture. And I should say, there's a balance between the lecture and then we'll have some examples. This particular lecture will be a little bit more heavy on the lecture side, and the example piece is a little bit shorter. And so a little bit more lecture, a little less example on this particular class. So we're going to talk about kind of a mathematical concept for what are spreadsheets, and in the introduction here, talk about what our theoretical goals are, and then really what associative arrays are. Getting into the mathematical definitions, what is the group theory, and then sort of leading into the sort of traditional linear algebra, vector spaces, and other types of things. Just sort of getting you a sense of, so this really is what connects those two things at the deeper mathematical level. So what are spreadsheets and big tables? So spreadsheets, particularly obviously Microsoft Excel tends to dominate the spreadsheet world, are arguably the most commonly used analytic structure on Earth. Probably 100 million people, if not a larger number, use a spreadsheet every single day. Perhaps a good fraction of the planet now has used a spreadsheet at some point or the other. Big tables, which are these large triple store databases that we have discussed in prior lectures, are really what is used to store most of the analyzed data on Earth. So Google, Amazon, they all have these giant triple store databases, which can be thought about as gigantic spreadsheets, really, rows and columns and values and stuff. And the power is that they really can simultaneously store diverse data. You can hold in the same data structure strings and dates and integers and reals and all different types of data. And you can treat them very differently. You can treat them as we've shown here. This is just one spreadsheet. We can treat it as a matrix. We can treat it as, functions, hash tables, little mini databases, all in the same spreadsheet. We can kind of hold this information. So it's a very powerful concept, the spreadsheet. Yet we lack any formal mathematical basis for this. In fact, I looked up in the American Mathematical Association and the SIAM databases the word spreadsheet. Okay? And it did not appear in a single title or an abstract, other than, say, maybe with reference to some software. But this core thing that we use every day, every single time we do a Google search, we're using it. Every single time we do a spreadsheet, we're using it. Has no formal mathematical structure. And so that seems like a little bit of a problem. Right? That maybe we should have some formal mathematical structure. And so this mathematical thing called an associative array actually gives us a mathematical structure that really encompasses this in a fairly nice way. I'm sure there's cases that it doesn't, but the core of what it is really, really works. So I think that's a powerful concept. So what is our overall goal here? So we want to create a formal basis for working with these types of data structures in a more mathematically rigorous way. This allows us to create better algorithms because we can now apply the traditional tools of linear algebra and detection theory to these types of data. It saves time in terms of generally, if you have the mathematical background, you can implement things using a lot less code, which usually means a lot less lines. And often you can build on top of existing optimized libraries, which give you better performance. And we throw out a number of 50x less effort for those with the required training. They can do this, and that is something that we've observed a number of occasions. And you know, it's good for managers too. I've tried to recruit group leaders at Lincoln Laboratory. It's like, you really should use D4M. I could connect it to SAP, no problem. You'll really, you know, and get them feeling like they're actually doing programming again. You know, haven't had too many takers of that yet. So.
And shut out my passports.
If you'll shut up and let somebody else talk.
And free speech, does that exist?
No, you've got it all.
And free enterprise.
We were talking of passports.
Today it's all monopoly.
All right. Now will you...
Can I go into the automobile business and compete with the auto trust?
If I can get in a word.
Not a chance. Can I go into the grocery business